a growing community of people on topics like fairness, transparency, accountability, and the like in machine learning. That's really, really exciting for many of us. But we're going to hear today about common pitfalls for studying the human side of machine learning. I'm really excited to hear what our speakers are going to talk about. We have three people who contributed towards this tutorial. Deirdre Mulligan, professor at Berkeley, unfortunately is not able to be here for reasons which are, in fact, directly linked to putting out fires. But we're delighted that we have Josh Kroll, a friend, a leading member of the FATML community, postdoc scholar at Berkeley, who studies the relationship between technology and governance, and Nitin Kohli, who is a PhD student at Berkeley, researching topics across privacy, security, and fairness. Our format is going to be similar to other tutorials, so our speakers will speak for about half the time, so up until around 12 o'clock, thereabouts. Then we'll take a break for 10, 15 minutes, and then we'll have the second part of the tutorial. Overall, we're hoping to keep questions towards the end, but if you do have any pressing questions, then our speakers are happy to answer them during their talks. Please join me in welcoming our two speakers.
Thank you, Adrian, and welcome everyone to our tutorial on pitfalls in studying the relationship between machine learning and humans. I'm Joshua Kroll. I'm a computer scientist by training, and I want to kick off the discussion today by talking about a tutorial that happened at this conference last year that was given by Solon Barocas and Moritz Hart, in which they noted that there's been an absolute explosion, an exponential growth, true exponential growth in the study of machine learning fairness. And a question that I have working in an interdisciplinary context, as I do working with a lot of social scientists and lawyers, is to what end are we pursuing this research? So we think it's a good idea to pursue research on machine learning fairness, but we're not really sure where to go from there. And so I want to take you with me on the sort of culmination of about a 1.5 year long odyssey that Nitin and I have been on to consider the ways in which different communities, different scholarly communities, and different communities of practice think about the kinds of concepts that we talk about when we talk about human-centered machine learning. I can't tell if it's this echoey because the room is this echoey or because the podium mic is also on. It's just the room. Okay. So I want to mention that when we talk about machine learning fairness, or accountability, or transparency, or interpretability and explanation, these are rich concepts. They have long histories of study in many disciplines, and those are concepts which, when we study them in a machine learning context, we should be aware of that history, we should connect our work to that history, and we should understand what results people have come up with in those other areas that might help us do our jobs better. Unfortunately, when we work in an environment like this where people from different backgrounds all communicate, we run into problems that are purely logistical, like vocabulary problems. The terms that we talk about get reused to mean different things, the same words, and that causes a lot of unnecessary misunderstanding and argument between people who are considering the problems at hand here. And so in this talk, we're going to examine the different ways that some of these words are reused and how that leads to confusion. And then we'll do some concrete case studies where we apply those learnings to actual machine learning problems that have come up in real-world contexts. I want to hand it off to Nitin now to keep going.
Great. Thanks, Josh. So before we get on this endeavor of looking at these common pitfalls, I want to first start by just explaining that today's talk is going to be separate from ethics, and it's kind of important to make that delineation up front. So that's not to say that ethics isn't important, because it most definitely is. It's just that people at this point in time are raising a lot of ethical objections to machine learning in different contexts. And there is a lot of value to this. But one thing we want to note is that because of this, folks are using ethics as like a grab bag rhetorical solution concept. And because of this grab bag rhetorical solution concept idea, it kind of gives this notion that there isn't agreement over what ethics kind of is. But that's not the case at all. We know this from before, from human rights, civil liberties. These are things that we already have made commitments about. So when we focus about these common pitfalls, we want to kind of examine these separately. And let's try to make this more specific, because machine learning is fundamentally a tool that's used to solve very specific problems. And because of that, if we want the future to look different than the past, we kind of have to realize that we can't blindly use machine learning for that. Notice I said blindly use machine learning, right? Because machine learning is a fantastic diagnostic tool. But if you want to use it in social contexts where there is historical prejudices, you don't want the future to look like the past anymore. As such, this kind of lets us know that when we use this tool for things that it wasn't designed for, it can do very dangerous things. And lastly, just why this isn't ethics as well is discussions of ethics tend to put the focus on individuals. But when it places the burden on the individual, it skirts around the issue that there are social, political, organizational incentive and dynamics involved as well. So by doing this, it actually ignores the broader infrastructure and environment around us. So like I said, we're not saying that we don't care about ethics, we're just going to hold that off aside to examine these common pitfalls here.
So in that vein, we often, as computer scientists, seek precise definitions of what we're talking about. We try to mathematize the problem and build a specification of the problem so that we can implement it. And that's important. We have to implement something at the end of the day. But how would we know that such a mathematization, such a specification is correct? What would it mean for such a thing to be correct? I put to you that these definitions of complex human values are unhelpful, but you actually still need to do them. You need to do them both because you still have to implement and because by specifying what you mean, either by some concept that you're trying to capture in a tool, in a product, just in a word that you're using in your writing, you have specified enough that you and other people can figure out what the limitations of what you're doing are. And there are a couple of reasons that the definitions, even once you've put them down, still aren't solving your problem. One idea, or one key reason for that is that human values are complicated, they're rich, they resist definition. And they resist definition in a really interesting way. There's a concept from the social sciences of what's referred to as essentially contested concepts. These are ideas where we agree on the notion that there is a concept out there for us to find, that fairness is out there, we should go and get it, but we don't maybe all agree on how to instantiate that concept in the world. So that means that when we try to look at a concrete instantiation, we're going to disagree about it. That disagreement is inherent. Similarly, definitions don't hold for everyone. So what's, say, fair for you might not be fair for me, and that might be true even if we agree abstractly on what fairness should mean in a particular context. So you have this problem in lots of concrete cases. A really well-studied one is recidivism risk rating. Which is the problem of if someone is arrested, we give them a score, and that score tells us whether we think they are, or what we think the risk is that they will be arrested again in a certain amount of time. Now, if we calibrate that risk to the actual level of risk that people encounter, what we find is that we give a higher level of risk to people of color and minorities in most jurisdictions because those people actually do have a higher risk of arrest, absent anything else, including, by the way, whether that person has in fact committed a crime or done anything that should be arrestable. And so that offends our sense of fairness. There's a famous article or series of articles in the media about how this offends our sense of fairness because it means that people of color get scores that are erroneously high more often than white people, and that seems like a bug in the system. It seems like something we shouldn't have. It seems like it's unfair. And yet, if we tried to solve this problem by breaking the calibration, we would end up in a scenario where the scores mean different things for different people, and that also offends a different intuitive sense of fairness that we have. And that leads us to the conclusion that if we want to capture human values in a system, it's not enough to look to mathematical correctness. We often think as computer scientists and machine learning researchers that if the models we build represent the data that we have and the data that we have represent the world, then we're done. We've done our job. We've done the technical part of the job. And these messy social problems, these human values problems, they belong to someone else. They can be outsourced to the lawyers, to the policy people, to the product managers, to the customers, but they're not our problems as machine learning people. But I put to you that is incorrect. These are not technical problems; they're socio-technical problems, problems in which we have coupled together people and machines and models and the whole of our society. And the technologies don't live in a vacuum. And if we pretend that they do, we've kind of put our blinders on and decided that we're just going to ignore any human values problems. And if we say that something is not my problem, then we've kind of disclaimed the responsibility that comes with what we want, which is the ability to use these technologies to do good in the world and to allow technology to take an important place and to really affect people's lives. I'll hand it back off to Nitin now.
Great, so now that we know we're considering socio-technical problems, let's look at how current approaches to fairness are discussed in the literature a bit. Not only looking at the CS point of view, but also looking from legal scholars, from sociologists and other folks as well, to kind of get a lay of the land at how these different communities are attacking this problem. But before I get there, I kind of want to just make a note that last year Kate Crawford gave a keynote at this very conference in which she gave a taxonomy of harms that can occur. She noted that there were allocative harms that can occur from unfairness, there are representational harms that can occur from unfairness. So these allocative harms are the ones where like an individual or a group of individuals have an opportunity or some object that is withheld from them, whereas representational harms are ones in which groups or individuals are subject to inordinate subordination due to certain things. But there's also even a third type that we can think of as dignitary harms that come from fairness as well. And for lack of imagination, dignitary harms are just, well, a loss of dignity. So let's actually start off with what is fairness, from thinking not as computer scientists or statisticians like I am, but just actually thinking about it how it works in the world. So like in law, for example. If we think about fairness as a process in the law, we have notions of due process of law. These are things that usually require notice, hearing, usually some type of trial or commitment by an impartial adjudicator. The notion of the fairness that occurs in these is because of the process itself, not the outcome that occurs afterwards. It's this nice idea that, hey, we have the ability to represent ourselves, and we also have the ability to contest outputs at every step of the way in terms of this adversarial setting that's set up with the judges. Another case in which fairness can be thought of as a process is actually in voting in some way. And this might seem a little funny, but when we take part in a voting scheme, we have an interest that we're relaying to the voting machine. So usually voting, right, at the most abstract level, I have a preference for candidates, and I want to submit that preference to a voting scheme that can somehow compute a societal preference, and then output an answer to who won the election. Now, we might say that even though the outcome of the vote, of the election, wasn't what I wanted to vote for, we know that there's a notion of this procedural notion of fairness simply because of the fact I was allowed to take part in the process. I was involved along the way. Much like in due process, I'm involved in the impartial adjudication along the way. A third case actually comes from GDPR, from our favorite Article 22, for those of us who are keeping up with all the articles. But this tells us that humans should be able to evaluate humans. And this actually gets at the notion of dignitary harms. So even if a model can do better on a task than a human, it's the idea that the decision needs to be made by a human because evaluations of this can lead to loss of dignity. So outside of the technical literature, we notice that fairness is part of a process, actually. But as technical folks, like I'm a statistician, Josh is a computer scientist, if we want to do math, we need mathematical objects, which means we need to define fairness in some mathematized way. And when we get to that, it turns out that our definitions of fairness tend to be more outcome-based as opposed to more process-based. So this might be things like saying the false positive rate amongst sensitive groups is equalized. Things that are very easy for us to measure and argue with. But when we actually make these fairness definitions, something funny happens. So in terms of like what fairness is, when we come up with a fairness definition, it's more like an invariant of unfairness we want to protect against, as opposed to saying the system is fair if this occurs. And because of that, it leads us down this funny path that we, as computer scientists and statisticians, argue about outcomes, but legal scholars, sociologists, philosophers talk about process. Yeah, that's that. The second thing I want to talk about is not only are there differences between process and outcomes, but that trade-offs are inevitable. And they're inevitable in a couple ways. So let's first think as more mathy folks why they're inevitable. A mathematical fairness definition essentially places a constraint on the behavior of a system. And this constraint is going to narrow down the class of models that could satisfy these conditions. So if we decide to add in too many fairness constraints to a system, some of these might be self-contradictory and cease the model to exist anymore, leading to impossibilities of fairness in which there's been so many papers written about. But even more so, trade-offs are inevitable in more of a value judgment way, in that when I choose what fairness definition to apply in a scenario, I'm making a trade-off with my own judgment into what is important in this case or not. Fairness looks different to different people. And what's kind of interesting is from the computational standpoint, like I'm guilty of this as well at times, is like we like to put things in a loss function and let it run, right? But Arvind Narayan at FatStar in 2018 had this great quote in which he said the usual like CS and stats approach is to throw everything into a loss function and optimize it to hope that fairness occurs afterwards. But that's kind of like counting apples in fairness and concluding that the total is 7. That doesn't make any sense, that when we actually toss things into a loss function, we're outsourcing the responsibility and the trade-off as well of the value judgment we made for the fairness definition we chose. And as Josh mentioned, fairness is this, essentially contested concept. We can all agree, hopefully here, that we want things to be fair, but we can't quite agree on how to articulate it. And that leads to this kind of uncomfortable notion, which I guess is kind of comfortable in some way. But it's once we have a definition, it will look different to different people, right? Fairness for one individual in the process will look different than fairness for another one. And the last point on fairness that I want to make is, maybe the problem is elsewhere. So let me unpack this a little bit more. So if we focus on fairness in machine learning or in our models in general, we kind of miss out on the fact that fairness might be able to be attacked in different parts of an environment as well. So let's think back to like risk recidivism that Josh mentioned. When we have risk recidivism, we're trying to attack this problem of creating a model that somehow manifests as fair or unfair by certain fairness definitions. But that completely skirts the issue that the environment in which the data was collected or that the model is deployed in is itself fundamentally unfair. So trying to only solve the fairness and the point of the model misses out on the fact that the world exists around it. And there are other unfair things that contribute to the development of it and also the implementation that occurs afterwards. So we can actually make this even more concrete a little bit more, right? Like, so let's suppose I want to build a model to decide if somebody I want to hire will be a good employee. But let's complicate this scenario a little bit more and suppose that I work in a toxic work environment. So because the work environment is toxic, a lot of our best employees leave the firm. So now what happens when I try to build this model of like trying to model what a good employee would look like, I'm actually building the model on a subset of employees who just decided to stay. And furthermore, when I actually design this system, it ignores the fact that there were certain attributes of the entire environment all around us that were unfair in general that might have led to certain groups of individuals leaving at a different rate than others. So in really, it doesn't really matter, like in some ways that you're building a fair system if the context in which it's deployed in or developed in is fundamentally unfair, right? Fairness is an essentially contested concept. The mathematical definition is something so narrow, but there exists a world around it.
So I'm going to turn away from fairness now to talk about some other concepts. The next concept on the docket today is accountability. And I think of accountability as a concept that fundamentally is about invariance. It's about what should be true of a system, and then functionally, where should we intervene on the system to guarantee that this is true? And I think of that following a little bit of a layered model. So at the bottom layer, the sort of most basic approach to thinking about this is to literally do accounting, to work toward accountability, to keep records. What is the system doing? How is it doing those things? What version of the system was deployed to make a particular decision? What inputs were given to that software? What outputs did it produce? What was its environment like? Can we reproduce its behavior? At the next level of abstraction up, we might look at those records, maybe take some analytics, maybe make some decisions based on how the system is doing. Maybe we find some bugs, maybe we fix those bugs, maybe we decide that some of those bugs correspond to errors or mistakes that people make. Maybe we mete out some kind of punishment for those errors, so we judge the system in some way. The sort of final highest layer is that we take responsibility, that someone is responsible for the system and its outputs and the outcomes that come out of those outputs. And so that's, I think, the important point about accountability is that it captures both kind of detailed notions of record keeping from the technical literature, from computer science. People often talk about accountable systems as systems where you can point out misbehavior through some sort of record-keeping scheme and maybe isolate it to a component, maybe isolate it to a particular change set. But when people talk about accountability in the law or in political philosophy, they mean something about assigning responsibility to humans. And humans are always accountable. You sometimes hear, I'm even guilty of this, right? The title of my dissertation was Accountable Algorithms. But algorithms are not accountable. Humans are accountable. Someone is accountable for the algorithms. And that's important to remember. And similarly, it's important to remember that we have to think about what the unit of analysis is. So we might, just like Nitin was talking about fairness in context, we can ask both for records at the level of an individual component, or we can ask for records about a whole system. The kinds of records we need are different, and they're going to depend on the particular invariance we want to enforce. They are going to depend on who the person is who is ultimately responsible, and what that person is responsible for, and what is going to be decided about in terms of, if the system goes wrong, is someone punished? Are we trying to remedy the incorrect decision somehow? That all plays into how we consider accountability. It's yours.
So following up on this idea that accountability was touching on, like, the when and where, right? It operated at different scales. We also find that transparency and explainability themselves are noble goals, but they're incomplete solutions in that they're missing operative words. Just how Josh kind of went through the when and where of accountability, the who, what, when, where, why, hows are important in specifying what these terms do. So as we're going to flesh out now, we usually find that calls for transparency and explainability are incomplete solutions in that they fail to specify transparent over what, or like transparent to whom. These user notions are actually very important in actually making meaningful and, I guess, sufficient notions of transparency and explainability for humans.
So in particular, transparency is often offered as a solution concept in a legal context. Lawyers will say, what we need here is more transparency in the system. And to computer scientists, that often means, well, what we need to do is make the code and data available. So we're going to put all the code up on GitHub. We'll post the data somehow. And I think this is not good enough for a couple of reasons. One, if we just do this, we've elided all sorts of decisions we've made along the way. How did we clean the data? how did we decide what data we were gathering in the first place? Is this just a data set of convenience, or is this some data that we actually went out to collect for a purpose, and we thought carefully about how we were going to collect that data? Also, the technical disclosures are, they help us, right? We look at them, we say, oh, anyone can check our work. They can go online, they can see what we did and how and why we did those things and engage with it in that sense. To the person on the ground level who's having a decision made about them by some sort of model, those disclosures aren't really useful or understandable, and so they don't help them gather any information about what went into the process. And that notion of what went into the process is also important. Often when we talk about transparency in a governance context, we mean something about participatory design. So often transparency is used in political science or public policy to mean something about people being able to come forward and put their preferences into a rulemaking process and decide what the rule should be, and maybe a process like the US has this law called the Administrative Procedures Act, which contains a process called the Notice of Proposed Rulemaking process, which requires administrative agencies to publish their plans and to take public comments on those plans and then to respond in writing to those comments. The other reason that transparency is not good enough is a purely technical reason, which is it's not the case that just disclosing all the code and all the data is first of all desirable, right? Maybe there's a privacy problem. But also it doesn't even help you get at the outcome. And of course you all know this already because you all know what a lottery is. A lottery is a process which is perfectly transparent. I tell you exactly how it works. You know exactly how it works, and it's very simple. Nonetheless, it is structured so that you cannot reproduce its outcomes nor predict them ahead of time. And that's interesting, and I come from a computer security background, so I can talk to you at length about how to build a reproducible lottery that would be possible to make transparent. I'm not going to do that today, but I think it's important to remember this as an example of things that are not served well by transparency as a sole solution concept.
Great. Thanks, Josh. So I'm going to actually go back one slide because it'll lead into explainability. So one thing that Josh kind of noted was that transparency alone, right, is an incomplete solution. Because let's imagine that I, as an individual, have an adverse decision made about me, and the company that does, I'm going backwards, I swear. And the company that makes this decision about me says, hey, look, my code's online, it's transparent, you can figure out why it occurred. Does this reasonably make sense for an individual? No, right? It assumes a lot of background knowledge. I have to be able to, well, okay, it's just Python, but like, you have to be able to kind of understand these things. It leaves out the transparent to whom aspect. So one thing that happens is folks can say, what about explainability? It seems a little bit stronger than transparency, right? I should at least be able to have a notion of how to communicate this out to folks. But this also, sadly, suffers from explainable to whom and explainable over what. What are you going to choose to explain, and who's the intended audience of it? So if we actually even just take a fundamental step back, right, let's actually try to remember, or even try to decide what makes an explanation an explanation. What comprises of the elements of an explanation? Luckily, somebody did this work for us. This was Miller in 2017. So Miller's a computer scientist by training. And he actually decided to read over 200 papers from the social sciences that were about explanations to say what makes an explanation an explanation. Because if we want explainability, we should probably know what an explanation is, right? And what Miller found out was that explanations took many forms. One form of an explanation was a causal explanation. So this would be like the answer to the form, why did event X occur? Alternatively, explanations can be contrastive. So instead of me saying, why did X occur, you might say, why did event X occur over event Y? So rather than purely putting on why did X in a relationship notion of contrastive. Miller also found that explanations were selective in that if you were to ask somebody why an event occurred, they wouldn't give you an exhaustive list of every possible thing, right? If you were wondering why I was late today to check in, I wouldn't tell you, oh, well, the elevator got stuck, then I pressed the wrong button, then I did this, oh, it was raining. No, folks usually actually just pick out a subset of relevant information to actually relay as part of the explanation. So the set of causes that are usually explained is, by definition, then selective. Explanations are social. That's great, right? Because ideally, the point of an explanation is to relay information. If it wasn't social, it'd be doing something very wrong. And lastly, explanations have this dual nature where they're both a product and a process. So they're a product in the sense that an explanation can be the answer to a question. But it's a process in the fact that it was social. It transmitted that information to another being. And because of this, we see that you need to understand notions of, like, if an explanation is social, right? Your explanation might look different if you're talking to somebody at this conference than if I were trying to explain it to my 3-year-old nephew, right? The audience matters. Explainable to whom? Also, what am I explaining? This notion of selectiveness is important to get at the explainable over what.
Thanks, Nitin. So we've gone through all the terms that we set out at the beginning. I should add as a parenthetical that when we started this project, we started with about 10 terms. We're not going to bore you with all of them today, but one of the interesting things we found is some interrelationship. I talked about socio-technical systems, so if I use the word algorithm in this room, it means something very specific and concrete, whereas to a social scientist, it probably means a system that includes humans, which is a little bit weird from a machine learning perspective, I think, from our background, but nonetheless a totally valid, conceptually integral use of language. So I want to turn now away from terms to some takeaway ideas, some lessons that we can take from the different ways that people conceptualize these ideas with different backgrounds. And one, I think, important thing to remember is that data are not truth. It's easy to sort of go online and download a data set and it's already in a CSV and you just throw it into your model and you're very happy because you got an answer and you got to think about some cool machine learning. But really what those data are an abstraction of the world. And that problem of how do we abstract the world into data is a really hard problem that every field that uses data in an empirical way, so computer science, physical sciences, social sciences, all have to grapple with this problem of measurement. And Hannah is nodding vigorously. I give her all credit for this. But I'll give you a quick anecdote about measurement, and that anecdote is about this man in the upper left, whose name is Lewis Fry Richardson, who's a British mathematician. He was very interested in the question of how he was interested in applying statistics to political science, and he was interested specifically in the question of whether the length of a national border between two countries would predict in some way the likelihood that those two countries would go to war over their whole history. And so he gathered a bunch of historical border data and set to work trying to put together the regressions necessary to answer this question. As he was doing that, he noticed something very odd about the border between Spain and Portugal, which is that when he looked at the Portuguese reporting on the border, it said the border was 970 kilometers long. When he looked at the Spanish reporting on the border, it said that the border was 1,230 kilometers long, which is a difference of over 20%. So that's a little bit weird, right? If I am standing at the border between Spain and Portugal and I walk across the border, it does not suddenly become 200 kilometers longer. What instead happens is that the border is measured in a physical process. That process involves taking planes and flying over the border and taking aerial photographs and then blowing those aerial photographs up really big on a table and using physical cartographers' tools to measure where the border is on that image. And Lewis Fry Richardson looked into this and discovered that the length that you measure when you do this depends on how much you blow the photograph up, on how fine the gradations are in your tools, on how skilled you are at matching up from one photograph to the next. So he wrote a sort of a research note about this, little curiosity in his data. That note, you might realize, foreshadowed or inspired work by another mathematician, Benoit Mandelbrot, who later wrote a paper called How Long is the Coastline of England, in which he introduced a bunch of what we now understand to be the theory of fractals. Now you might be thinking, because of that, you might say, well, Josh, length, it seems like it's an easy, conceptually integral concept, that nonetheless has this sort of strange mathematical bug. Right, we know that if the Hausdorff dimension of a curve is strictly larger than its topological dimension, that the behavior of measuring length along that curve is weird and sort of poorly, not poorly conceptualized, but it behaves poorly. It's poorly behaved. And it leads to these weirdnesses, and the only kind of mathematically useful answer that we can come up with is that the curve is infinitely long, which is not a useful answer for the purpose of this study. But I put to you that if length is difficult to measure, and yet it seems so easy, that maybe all sorts of physical phenomena are actually hard to measure, and in fact, social phenomena are hard to measure because the physical phenomena are at least observable, right? We can go out, we can observe them, we can build tools that observe them, but lots of the concepts that we want to capture with machine learning or with scoring systems of one kind or another are unobservable concepts. They're purely theoretical concepts. They don't exist outside of our models. These are concepts like risk, like intelligence, like how much a student has learned in a class, propensity to crime, things like this. And this is not a new problem. This is not a problem that machine learning has hit for the first time. This is a problem that social scientists, people who design tests especially, are very interested in this problem. And they've come up with not a solution, but at least an approach to reasoning about this problem that goes by the name of construct validity. So construct validity contains a lot of the validation that we do of our models in terms of measuring predictive accuracy, looking at the various rates of performance of the model, various measures of performance, but it contains other things too, like validating that the mechanisms that are captured in a model or in a construct match up with a coherent theory, match up with other work that's been done by other people on the idea. And I won't talk in detail about construct validity. I just want to point it out to you. There are several authors, depending on who you read, there are something like 5 to 9 ways that you can define construct validity, different approaches to talking about validity. And I think it's important when we do machine learning to understand that when we measure accuracy and precision and recall and all the measures that we use, we're not done. We haven't fully fleshed out the performance of a model in that by doing that kind of analysis.
So just as Josh was talking about, right, data is an abstraction and measurement can do these weird, funky things. It's important to remember that just as data are abstractions of the world, models are abstractions of data. And because of that, it kind of leads to this notion that models are really nothing more than mathematical fictions. Right, they allow us to formally reason about the world, because in order to formally reason with math, you do need mathematical objects, but they can be wrong. And I do concede this point, right? Like I'm a game theorist by training. The utility functions that I work with for incentive compatibility are fictions or compact representations that allow me to understand the world. But that's the thing, right? Mathematical fictions are just that. They're models. That's all they are. Don't let the math cloud your thinking, basically. The world adapts to everything that's around you.
So with that, I will kind of drive home this idea that there's no actual substitute for solving the problem that you have, which involves thinking hard about what problem you have and then solving it. And too often we outsource the problem in some way. And I see now that we've talked about construct validity, Hannah's going to leave. I knew that was coming, but glad you were here at least for that part. So too often we outsource either defining the problem or solving the problem in some way. So the simplest way we do that is we outsource solving the problem to data. So we say we don't know what patterns in this data are useful or even where the patterns are or how to look for them. But the machine learning algorithm knows. The machine learning algorithm can tell us. We'll just apply it to the data and it will come back with the patterns and we'll say here's a trend line or a rule that you can apply that generalizes pretty well. But that doesn't actually tell us about the phenomenon that we're considering. It doesn't answer a question. Similarly, we often outsource problems to end users. So maybe imagine a scoring system which generates a score. So there's some curve that's generated by the scoring system which represents the phenomenon under consideration, maybe risk of criminal recidivism, let's say, just for concreteness. So when we try to use that curve to put people into categories, so we want to use that curve to say these people are high risk and these people are low risk, and we're going to divide them as such and treat them differently based on that division, we're going to outsource that thresholding to a customer, to a consumer of a model, to some user of the model, and they're going to set the threshold, and because they set the threshold, it's not our responsibility to set the threshold. And nonetheless, by doing that, we've not thought about what are the fitness of the models we have, of the parameters we've set in those models, of the defaults we've set in our products for any given purpose. It's important to think about those things and communicate the limitations of the tools to the people who are ultimately going to use them to do some important thing in the world. Before we do that, we have to be able to understand the problem. That means that we have to take these abstractions that we've built, the data sets that we have, the models we build out of them, we have to connect them back to the world. We have to think about construct validity. One way to do that may be to involve domain experts, to go out to people who actually have world knowledge, who've spent their careers developing knowledge about criminology or teaching students or healthcare, whatever it is, bring them in and say, hey, these patterns that came out of the data, are these real patterns? Are they noise patterns? Can I trust them? Are they going to fall apart? Are they robust? All the things that we want out of these systems. So I'm going to turn now away from this sort of theoretical discussion and toward a concrete set of cases that Nitin and I put together around how we might apply some of the ideas that we've talked about for the last 45 minutes to real machine learning systems. And so the first case is a rating system, a risk rating system for babysitters. So imagine some company, we'll call it X Corp, is launching a new service. And the way this service works is people feed their social media data into the service, and it predicts whether or not that person is likely to be a good babysitter. Well, what's a good babysitter? Someone who doesn't abuse drugs and someone who doesn't have other undesirable tendencies like aggressiveness or disrespectfulness that we might care about to hire to supervise our children. So using machine learning and other computational techniques, X Corp's product is going to produce a score from 1 to 5 and display this to the hiring parent. And so a question that I want to put to you is to think about this case, which I'll put back up in a second, with your neighbor. Talk for 2 minutes about this case, what you think of it, how it makes you feel, whether this approach that I've described is sort of valid in the way that we would need it to be to solve the problem that it's supposed to solve, and then also what concerns might we have about such a tool, and who might have those concerns. So go ahead, take 2 minutes now and talk to your neighbor or text with someone, Signal, whatever it is you do. Go ahead. Go on.
Problem solving's a team sport. Make a friend, you know, like.
If you have no neighbor, Adrian is down here in the front. He can join your group.
How do you want to handle this?
I've done all my talking.
Take the slide, I'll take the next.
Did you note the time when? I don't remember when we hit 2 minutes.
Oh, we'll start now. Let's go till 50. 37 onwards. 36, I think you'll do better of.
Okay, so what am I saying here?
Oh, we just wrote down possible things, but we didn't fully flow that.
Yeah, Goodhart's law is good. Should we bring people back together?
Tell them like, oh, 1 minute remaining or something. Or just like last 30 seconds.
We just bring people together when it's time. All right, let's come back together. So I want to start by describing a couple of thoughts that we had about this question. One being that this is a static approach, that there's a sort of adaptiveness to the world. When we put measures on the world, it sort of tends to respond in a way that makes those measures arbitrage away or disappear or become less useful. This idea has a name in economics. People call it Goodhart's law. So that's, I think, worth remembering, that if we deployed such a system, people would change their behavior, change their social media posting behavior to deal with the way that it might affect their lives. And then similarly, you have a sort of a question about how would you evaluate the robustness. So how, if I'm a 5 out of 5 today, how do you know that I'm not a 2 out of 5 tomorrow? And the other way around. What do these scores mean, and how do we know that they're stable? Where do they come from? And so let's move on from this question to another question. So, oh yeah, sorry. Did anyone have any other ideas about that? You can just raise your hand and then shout them at me, and I'll repeat them because it's a big, huge room. Yes, in the red shirt.
Oh, it is. Okay, cool. So personal and professional behavior, they're not perfect signals because how you behave in your personal life is not necessarily the same as you would behave in your professional life. Also, using social media doesn't necessarily, there's a lot of noise there, and it indiscriminately would punish people who are more open on social media versus maybe there are individuals who are despicable who don't share enough on social media that might just get away with it. So, and I can keep going on, but I'll stop.
Yeah, I think that's exactly right, that social media data maybe does not capture the kinds of inherent despicableness that we might hope to capture with some sort of score like this. So moving on to another question, take, I don't know, another 30 seconds to a minute to talk about what it might mean for this system to be fair. If we said we want the system to be fair, how would we operationalize that? What would it mean? So go ahead and just quickly chat about that. And then Nitin will bring us back together in about 30 seconds or a minute.
Uh-oh. Yes. This goes the opposite way, I think.
Hot corners is a disaster. Going to do the next two.
friends, let's talk what it would mean for this system to be fair. So I'm curious at what you all thought about. If anybody's brave and want to raise their hand, I can repeat the question, or repeat what they said, or I can start too, whichever. What would it take for this system for babysitter risk prediction to seem fair? Yes.
Okay, I'm gonna keep coming up because this is the kind of work that I do for most of my work anyways. So like a feedback system would be something that's useful, and I guess you guys sort of alluded to that, but my colleague and I, Mike, and I sort of got into an interesting discussion where feedback systems are inherently polarized when it comes to how ratings are distributed. Like the canonical example for that being Uber ratings. Like you have to have a really horrible experience to give someone a 1. And if you have a moderately horrible experience, you give someone a 4. Everything else is a 5. So that bucketing on the scoring system, like it doesn't really work. And I guess like what Mike and I were talking about was that we're, as humans, sympathetic to each other. And that sympathy doesn't translate well into a rating scale or a number system. So anyways, I don't know, like feedback tools could be an effective way or perceived effective way to do it, but it has like a bunch of flaws.
I like that idea, kind of tied to the notion that we hit before about fairness maybe more as a process. Any other ideas? Yeah.
I think that in order for this system to be fair, it needs to give an indication of how this person would perform as a babysitter. And that is not actually what the way you framed it in the beginning. You are framing it in terms of whether they do drugs or whether they sometimes speak in an angry way to some of their friends or something. Mm-hmm. And that's not actually what the end user cares about. That person could be horrible to their friends all they want, and as long as they do a good job of being a babysitter, the end user doesn't care, right?
I see. So one way we can take that is to think about maybe the construct we're measuring wasn't appropriate for it, and also thinking about fairness from the individual potential employee point of view. I like that. That's great. Yeah.
Yeah, I was going to add that any system which generalizes too much and says that there's 5 factors which make a good babysitter or whatever, they tend to oversimplify the problem. It's very easy to get like a bad prediction. And that seems like for any system like this to be fair, you have to have some kind of appeals process where you get your specific information reviewed to see if it's some exception to the rule.
Right, I like that idea. So that actually ties with some stuff that Josh and I wrote down, so I'll just tell you what Josh and I kind of thought about this. So we thought that we could look at fairness kind of more at like a little micro level and at a macro level. So when we thought about the macro level, we could say that, for example, like it would like, are we grading people accurately could be one notion of fairness. And let's hear this out, right? Because you don't want to tag me as being a drug offender if I'm not a drug offender. That would be particularly unfair to me as an individual. But if we think more at the macro level, at a higher level about this, babysitting is actually low-wage work. And it might be the case that babysitters don't have much of a say in this to opt in or anything in general. So it creates this awkward power dynamic at the macro level as well. Furthermore, some of the folks who spoke out kind of mentioned, if someone gets a score wrong, we need a process for understanding what that score means. If I give you a number from 1 to 5, we actually didn't even tell you if 1 was good or 1 was bad, but nonetheless, we have to figure out what that score means. And like, why did the person get that rating, and possibly try to create more of an appeals process or a dialogue around it. Even more so, what's fair for the employer, like the parents in this case, might be different than what's fair for the employee. Employers, in this case the parents, might want somebody who's like really angel-like to take care of their little darlings, right? But from the point of view of fairness for the individual, it can be, yeah, maybe I posted some lyric online that somehow thinks I use offensive language, I'm aggressive now. So this notion of like not only transparent and explainable to whom, but also fair to whom. Fair over what? What are the attributes that are being brought in, like the gentleman mentioned, like maybe only 5 criteria. Fairness over what? Fairness to whom? These terms are missing all those operative words as well. And these are by no means exhaustive, right? There are lots of different cases here. So let's talk about the next question. This is suggestive in some way. What would we need to make the system, I guess, sufficiently transparent, where that is determined up to you all for the next 30 seconds to a minute? talking, I thought they were going to. So I guess they did self-select to come to this. So.
Yeah. I'd say also people who aren't interested have opted out by going somewhere else. All right, let's come back together, and then if you have something you'd like to share with the whole room, please come to one of the microphones, either on the right side here, or on the left side here in the center aisles, and we can share some thoughts about transparency in babysitter risk rating. Yes.
Okay.
It's on.
Is it on? Okay. So in thinking about this question about what would make the system sufficiently transparent, first, I think if people know that if they're going to rate someone, that person will know who's rating them. That might be something to think about. Also having a diversity of recommenders or raters, because one parent could see something one way, another one could see something another way, and not just putting out that first score that maybe the first parent gave in that whole recommendation pool. I did like the appeals process. I thought that was fair, because I think if both parties know that that can happen, then you're going to probably think about what the real situation was and whether if you want to be involved in that process. And then also have a large enough question pool, because if you do just have one question, that can lean a lot of different ways. So if you have maybe questions that involve the activities that you did with the child, or how you punish the child, or if you worked with them on homework, that can probably add into the making the scores a little bit more transparent.
Yeah, I think that's those are all great points that feed into sort of this question of system dynamics, and it's hard in a system that's dynamic, in a social media context, to figure out what's going on at any particular moment, right? Maybe something you said was in reaction to a joke or a meme that's of that particular day or of that particular hour, and just for my own curiosity, how many people still make jokes about Covfefe? Anyone? No one. Right. So that's going to be out of context, and so that context is important. Yes.
I was going to say that it may be impossible to make the system.
Sorry, I think your mic is off.
It may be impossible to make the system sufficiently transparent, because the nature of taking data from social media is slightly coercive. So if you're then sharing data that you force someone to give that they normally view as more private, and you're starting to explain over that data to people who aren't even that individual, you can create a lot of problems.
Yeah, I think that's a great point, that if we're not using data that's relevant to the problem that we're actually trying to solve, it might in fact be impossible to be sufficiently transparent about what we're doing, because once we've made ourselves that transparent, it becomes clear that the answers that we've come up with don't have the meaning we would want them to. So just some stuff that Nin and I had talked about before the session about transparency here. One is reproducibility of scores, right? Can you actually not just explain how a score was achieved, but demonstrate how to calculate that score? Figure out what features should go into that score, and that leads us down a different rabbit hole of causality that I don't really want to go down too far, but we do want to know that the mechanisms that we've captured are sort of meaningful. There's a privacy aspect to transparency, right? So if people are opting in to giving their data to this system, do they have control over what goes into the data or not? Is this all your posts? Are these just your public posts? Are these just posts that you've shared with the system that you've curated to be representative of you in some way? So having an understanding of that, I think, is also interesting. And then I sort of set explanation aside, but I do want to bring it back, because if we want people to understand what's going on in the system, I think it's very much the case that we'd like to be able to explain to them how their score was calculated. So you were a 4 instead of a 5 because you should have had more better or fewer rap lyrics on your Twitter feed. So that explainability point brings me to our penultimate question in this segment, which I'll give you about 30 seconds to talk about, which is, do the concerns that we've talked about, do they go away if we find a way to give those explanations, or to what extent do they go away? I guess we might ask. So go ahead and take 30 seconds with your neighbor to talk about that.
Oh yeah, we have just 2 more 30-second things, and so by 12:15. Yeah.
10
Do you think 10 might? Because we just have one more case study, and that's it then.
Yeah, and then do questions.
Perfect. That's great. Thank you.
So you're at about 30 seconds.
I'll go a little more. All right, let's talk about explainability. So what do you all think? If we were to try to explain outputs, would this kind of alleviate concerns?
Take a vote.
I see somebody's coming up, but yeah, you can speak as well too if you want.
Repeat it for the. So the point was that it depends a lot on context, is how I take it, and sometimes there's a context where if there's a particularly problematic child, for example, maybe babysitters don't interact with that child in the same way, and I think that sort of generalizes a little bit to the social media setting to say that people may treat others on social media in a social media environment differently based on who they are. So for example, my Twitter responses to Nitin might be very different from my Twitter responses to @RealDonaldTrump.
Yeah. There was another gentleman who was making his way up to the mic.
Yeah, I think to a large degree it depends on what sort of data the system is analyzing. So for example, it wouldn't be solved by explaining the outputs if you have any explanations that are relating to, say, a friend graph, because your explanations are helping users of the system perpetuate their own biases. So for example, if someone goes to an inner city school, you look at their friend graph and might conclude that they get a low babysitting score. From an ML perspective, it may well be a good predictor, but you aren't actually analyzing the person, you're analyzing their network of friendships. So it's a highly biased and highly problematic instance. But as a parent, if you read this person has a lot of friends who use drugs, that's probably enough to not hire a babysitter, even though it's not directly on the person. So you're creating a lot of bias.
Yeah, so just, I apologize, your voice is has a very similar register to the air handling, so it's a little bit challenging to hear. But as I understood the point, it was that the context of people's features might change as well. So if I explained to you that your decision was poor because of some fact about your use of language, that might be due to the fact that your friend graph places you in a context where your use of language is different from maybe what the model was expecting. That actually reminds me of a very cool result from Sulin Blodgett and one of her grad students. I think she's at Dartmouth, but I'm sure that's wrong, and someone will come and actually tell me it was the University of New Hampshire. Somewhere in that part of the US. If we take social media posts in African American vernacular English and we feed them into sort of standard NLP language detection models, it turns out that many of those posts are in Danish. Who knew?
So yeah, other things that Josh and I thought about for this question, right, are concerns with the system solved by explaining the outputs. We thought that, well, if the extent of the explanation was just described at how the score was computed, then probably not. Right? That's not actually solving the concerns we raised about fairness and transparency. But what if instead the form of explanations takes this instead? Right? So instead of actually just saying like how the score was computed, what if we actually give like a subset of posts that say these were things that the model flagged as problematic to create a dialogue between the potential employer and the potential employee? That has a very different use of what the explanation is used for in that case. So even more so, right, if the tool were to just rate people in such a way that it's either hired or not, right, there was no human in the loop, that would also be problematic. But once again, right, if you actually use this to facilitate conversation and realize that, well, maybe I can use these explanations to open a dialogue and create a process, then it might seem like explanations can be valuable here. And I think I kind of stole the last talking point for one of them of possible solutions, but nonetheless. Right, so instead of just giving a score, why not give people a potential list of posts that are of concern? We know from Miller's work that explanations are selective. I can find a subset of things that the model thought were concerns kind of as a diagnostic tool in some way, as opposed to blindly just trying to predict like if somebody should be hired immediately or not, to create this dialogue, to start that process. I'm gonna actually say we should probably take a break and, oh yeah, even more so, better yet.
How would you handle the context bias problem with the giving sets of posts?
I think that's an excellent question. The question was how would you handle the context bias question with this approach of giving a subset of posts as opposed to just a score? I think I would answer that question with another question, which is I don't know the extent to which it's very possible that a large portion of the context bias question is captured by the context of hiring, right? So maybe it's the case that the places you're likely to be hired as a babysitter are similar enough to your friend graph or similar enough to that context that you can take the posts out of that and present them to an employer in a similar enough context that they still function in a useful way. I don't know that that's the case. I just hypothesize that it might be, and that's something that we can measure. Do you want to wrap up the? Yeah. So we're going to take a little bit of a break, but before I get there, this actually wasn't a hypothetical case that we made up. This we pulled from actually a Washington Post article in which the headline was "Wanted: The perfect babysitter. You must pass an AI scan for respect and attitude." So this was actually a real case. It wasn't a hypothetical. We just made X Corp up instead. But yeah, if you want to read more about it, the link is there on the Washington Post. It's kind of a fascinating article. I should add, too, the other non-hypothetical version of this is that Immigration and Customs Enforcement in the United States wrote a procurement document last summer in which they said they wanted to evaluate people based on their social media data for their propensity to commit crimes or terrorist acts, or to, what the procurement document said was, be a positively contributing member of society. I don't know how to write a loss function for that. If you do, please see me at the break, which is now.
Yes.
So we'll break for about 10 minutes. We'll come back together at 12:25.
20, yeah.
Okay, great. 8 minutes.
part 2 of the tutorial, and just to let you know, this should be about 20 minutes or so, and then we'll have questions running until 1 o'clock. One favor to ask, please, is when we do get to the question section in about 20 minutes, please don't leave and start being noisy if you're not interested in staying for the question. Stay if you can. If you do feel you need to leave, then please try to leave quietly and move away before starting to talk outside. Thanks very much.
Great. So welcome back. So we're going to think of a separate case here. And this case is going to be actually about law enforcement facial recognition. So moving away from the babysitter AI from before. So in this one, here's a scenario. There's a police department in the city of Yville, and they want to be able to identify criminal suspects in crime scenes videos to know if the suspect is either known to detective or has been arrested before. So a company called Z Corp offers their cloud facial recognition API. And what the police are going to do is they're going to build a system that uses this API to query probe frames from the crime scene video against the Yville police mugshot database to see if they recognize the individual from the video. So yeah, we're going to have kind of a similar dynamic as before. We're going to pose some questions, let you all make friends, and talk about it, then bring it back together. So I'll go back to the previous one in a second, or if you want to take a picture, here it is. I'll go back in a second. But the idea was, like, the fact that this is a government application, how does it change anything about the requirements from the first case, if at all? These are tough questions. Make a friend. Have some fun. I'll go 2 minutes. You should talk about this one. Because I'm going to make a bollock of it.
Conversation during the break.
Yeah. So
Debrief afterward what people's reactions were. What came up.
one of the guys, he was a professor at Berkeley. He's Chris Evans. His dad is Craig Evans, the world's like badass PDE guys. And he does stochastic differential equations. I was like, you're like the last guy I thought I was gonna see here. Like, I was in industry making bank.
PDE knowledge.
Yeah.
And some trading models. All right, I see a lot of good discussion out there. I hate to break it up, but if we could kind of come back to order. If you have thoughts on this question, please use the mics. The question is there a difference between the previous case where the application was a private company selling a service to consumers, and this case where the service is being deployed by a government agency? So anybody have any thoughts on whether that changes the fairness, transparency, accountability requirements? Yes.
Hello. Okay. So I think when it comes to a government application, there's obvious compliance with some of the legal requirements. As an example, in the US, it would be the Freedom of Information Act. So maintaining the records in a manner in which you can fulfill those requests if they come in, maintaining privacy and complying with all of the other sort of regulatory pieces is something that would differ when it comes to a government context.
Yeah, so that's definitely one important point, that government agencies are often subject to much stronger regulatory requirements. And there's one other comment here. Yes.
I was going to say just counterpoint to that. There's also such laws like the Patriot Act, which basically prevent that information from being transparent. So I mean, in the sense that if it is a government application, and depending, in this case, it's being used for security purposes, you have the inherent disconnect between the government, who does not want to explain or have anything transparent, versus the actual end users in this case that are being affected by it that would like that transparency.
Yeah, I think that's an important point, that not only do government agencies have higher regulatory burdens in many cases, but we shouldn't believe that by satisfying those higher regulatory burdens, we've somehow made these problems go away, and that actually the regulatory burdens may not, in fact, solve the problems that these systems are really bringing forward. I do want to think a little bit more abstractly about the government as a sort of representative body of people. Think about governance, not just governments, but that when a government uses a system, there is a sort of public interest, social interest in having an input to what that system is and how it works and what it does and whether it mediates the government's policy into the world in a way that we're comfortable with. And that's something that maybe requires some, not just freedom of information laws, but other things like notice laws, right? Do we publish ahead of time what the system is going to do? In the US, the first transparency law or the first technology-focused transparency law was the Privacy Act of 1974? 1974, which required that agencies publish what are called system of record notices that define when a database about citizens is being created. They define what data is going into it, and some other sort of very high-level details about the existence and scope of that system. And so that doesn't maybe help us answer questions like, is the system going to be equitable to people of all races? But it does allow us to use tools like freedom of information laws or other policymaking tools to start to explore those questions. So that's interesting. Let's now take about 30 seconds to talk specifically about what those fairness equities in a police face recognition system might look like, what might go wrong here. So go ahead and find your neighbor and take 30 seconds to do that, and then Nitin will bring us back.
God, I hope so.
Train data files.
Self-fulfilling prophecy kind of stuff, yeah.
Predictive policing.
In fact, there's the data, have you read the Data Mining Moratorium Act of 2003? And predictive policing under the Total Information Awareness Program. But for some reason, the government was, because they said there was no evidence it worked. and yet, like, we allow private companies to sell this stuff for like state agencies.
The other thing I would say here is that there's an automation bias problem. So suppose that what happens is you submit a probe photo and you get back like 5 or 10, whereas is done in New York City, 250 photos of potential suspects. Right? What do you do with that? And then the other fairness issue is like who's in the background set.
Yeah. So on this one, I think we might pass it back and forth. Like if you feel I missed something, feel free to, of course, jump in.
Yeah, that's good. We're
Also, we can go into the fact that facial recognition we know doesn't work
Any
well.
opinion about this? I had no idea he was here.
Oh, nice, yeah.
Do you see him? I don't see him. Who's David? David Robinson? He's there. He is.
By the way,
He's at Cornell. He founded Upturn with Carl and you.
Oh, nice. We can talk also about how facial recognition doesn't work well for people of color.
Yeah.
Yeah.
That's a training group.
Okay.
Talk about the Joy Long study.
Yeah, we can also talk about how back in the day when photography was done, the camera chemistry is different for people of color versus their I don't want to call it non-colored counterparts on camera.
We're almost up to 2 minutes, by the way.
Yeah. All right.
We're over 2
All right. So, what fairness equities are at stake in this system? What have y'all talked about? we can talk too, but. Want to lead or?
Yeah, so it's a little bit strange to talk about fairness, I think, in the context of a police investigation, because we often think of police investigations as, Scotland Yard always gets their man, or that it's important to get the right person, not just to, bring in an equal number of white suspects and black suspects and female suspects and whatever other protected attribute you want. That there's a sort of ground truth that we believe in. But what might make that challenging then?
Yeah, so one thing is lots of issues with just training data, right, with facial recognition systems. So back in the day when cameras were developed, the camera chemistry is actually different for people of color versus lighter skinned folks. So this actually changes.
Photos, in order to make it possible to photograph light-skinned people accurately, the camera chemistry was calibrated, film chemistry was calibrated to enable that, and a side effect of that calibration was that it didn't work very well to photograph dark-skinned people. And that behavior, that performance was copied in the calibration of early digital cameras so that they would behave like film cameras and be acceptable to consumers as a kind of natural substitute for a film camera. I think the other training data bias issue is that face recognition systems are often pipelines. So you might start by detecting a face and then close cropping it and then passing that off to some sort of system, probably a semantic embedding system, and then you learn from that an embedding that allows you to get out to an identity at the far end. So each of these stages is trained on separate data, and you have to ask yourself, do those data at every stage represent the population to whom you're applying the face recognition system? Because you're really only bringing the background set, the people who are possible to be identified by the system, in at the very end of the process. But maybe the features you learned to try to distinguish these people from each other don't actually represent that population of people in a meaningful way, and so won't do a good job of distinguishing among people. And actually, a similar kind of lookalike problem comes from the way the system is used, right? So if you imagine, what is the UI for a detective using this system? Well, they're going to have their crime scene probe photo, which is like a low resolution or maybe blurry piece of surveillance footage that they've gotten a good frame out of. They're submitting to the system. Maybe they submit the whole video to the system and it finds the frame. But what comes back is a set of photographs, probably. I mean, maybe it's one photograph. It's just like, this is Bob Jones, who we arrested 3 times last year, and here are his mugshots, and you can confirm that it's really him. So you have this sort of investigate and identify workflow. But maybe it brings back a bunch of photographs and says, hey, here are a bunch of people it might be. And now you've presented the human with a problem that humans are actually not very good at, right? If I show you a bunch of 5 photographs of people who look very similar, which one is the one in the photo you started with? Hard to say.
Yeah. Cool, so let's spend another maybe only minute and a half, because Josh and I like to talk a lot. Apologies for that, and we want to make sure you ask questions. So what's the role of transparency here? We kind of already touched this a bit, so. I'll just actually go to the next slide and then say, like after a minute, I'll be like, okay, now that we've thought about it. I'm just gonna say, like after we do this, say, now we thought about transparency. Let's talk about explainability real fast, and then just flip to the next one, so we can just discuss them both at the same time.
Yeah, I don't think the next slide to me is about accountability. I want to make it clear.
Oh, yeah, okay, fine. Oh, shoot, you're right.
Accountability is not only a public sector concern.
Yeah, okay, we'll just skip, or should we skip the what form could explanations take, because we're going to run out of time. Yeah. All right. Actually, I'll let you drive this, because you know the facial recognition stuff much better, so yeah. Huh? What is the role of transparency?
So I'm going to bring everyone back together after a minute and a half because we want to make sure we leave enough time for questions, and it's already 12:44. So anyone have thoughts on transparency in this system? Otherwise, we'll talk about what Nitin and I thought. Yes.
My answer should not be very good because I'm not very familiar with
That's
this
on,
concept.
and if you pull it, if you turn it down a little bit, there you go.
Sorry. Just think that something that is important for me is that if we have some transparency, it should be along with responsibility. We need to feel that okay, there is a failure for judgment, and we show everything, so we are transparent, but we are feeling a responsibility for the failure, and maybe responsibility could be considered.
Yeah, so I think that's exactly right, and I think it's important to recognize that we're talking about these concepts today in a very separate way, in a very kind of taxonomized way, and that's not right. When we're talking about what makes this system trustworthy, what makes it possible to deploy this technology in a way that's useful and gives people sort of warm, fuzzy feelings about the technology, as opposed to believing that the robots are taking over and we're all going to die. That's kind of a coherent concept, and we break it down through this lens of fairness, transparency, and accountability. But those concepts sort of lean on each other, and they're related to each other. So I think that's important. Did you have a point, or?
I think there's also a role for kind of social advocacy as well. Like, this transparency is kind of necessary in protecting the people that we're trying to protect. If this is a security application, then we have to understand that there are usually implicit assumptions made in criminal justice, such that ex-cons are like some of the least. Basically, ex-cons have like the least rights of anybody in society, and just basically like there has to be a transparency of process, a transparency of thought that goes into making these systems actually just, and making sure that we don't continue to marginalize people who are already likely to be oppressed.
Yeah, that's fantastic, and I agree, and I think that we often miss the idea of transparency as a sort of participatory design exercise, and if that happens at a social level, then that happens through some kind of policy-making process, and that's interesting because a lot of these tools are not produced out of policy-making processes, but they're produced out of procurement processes, right? I mentioned that Immigration and Customs Enforcement was trying to build this social media monitoring tool, which would try to collect information and make predictions that had very little construct validity, if any, that system was described and discovered because it came out through procurement documents, and those procurement documents have to be made public, which is a transparency tool. But there's also a transparency tool, set of transparency tools that say that the public should be able to pitch in to the design of policies, and maybe machine learning systems are not products that we can just take off the shelf and apply blindly in a new context, but actually policies that government agencies are developing and should maybe develop in-house, and that should be more of a negotiated process that includes activists and social activism. I should say that the coda on the ICE system is that ICE did drop the procurement after activism by a bunch of social action groups, and also a few hundred or maybe 60 some machine learning researchers who signed onto an expert letter arguing that the system was unlikely to work. I'm going to skip over the remaining two questions, which are about accountability and explanations, because we are out of time, unfortunately, and just move to our close by saying that this is also not a hypothetical case, that Amazon, sort of poorly disguised as Z Corp, has a face recognition API. That API is used by and marketed aggressively to police departments around the country. The ACLU did a test where they gathered some publicly available mugshots and loaded them into this product, and then queried against them with the official portraits of every member of the US Congress. This is actually, for full disclosure, a project that I worked on, not in the design or execution of the study, but in replicating it before it was made public. And they discovered in the study that about 17 members of Congress, something like that, were 28 members of Congress were identified. 20 members of Congress were identified. Oh, 28. It says right in the headline. Am I not reading my own notes? The 28 members of Congress were falsely identified as being in the mugshot set that were gathered from publicly available sources of real mugshots in California, which did not contain mugshots of any members of Congress, which is not to say that there are no members of Congress with mugshots. So let's jump quickly into our closing slides, then we'll take some questions, and then we'll wrap up.
Sure. So overall, what have we learned from these cases? Well, the first thing is that to solve problems with machine learning, you kind of have to understand them, understand their context of use, understand the context in which the data was collected, understand the context of the development. And in particular, right, this notion that data plus machine learning or data plus deep learning or data plus computational tools will just solve a problem, it isn't really an answer, right? It's an invitation to ask more questions. Machine learning is a fantastic use in these social contexts as a diagnostic tool. Use it as such.
I think the other thing we want to remember is that different people or different groups of people are going to define the problem in different ways. They're going to see different parts of the problem as being the key components of the problem, and we shouldn't believe that the way that we want to frame the problem computationally, or the way that we would have learned in our Machine Learning 101 class, is the right way, and in particular that's expressed in the ways that different communities use words like fairness or even algorithm. And that's something that Nitin and I should have a paper posted on the internet any day now. So we're very excited about that. To close, I want to say that if we believe that the systems that we build should include people in society, it's incumbent on us to make them reflective of human values, and that process is a process. It's a negotiation. It's not something where we can just define those values and then apply them to the rest of society and believe that that will somehow work or be acceptable. So to wrap up, Nitin, you had one more point.
Yeah, there we go. There's no substitute for thinking, right? So much like we saw there's no substitute for solving the problem, we can say a similar thing about understanding problems and just problem solving in general. So there are lots of taxonomies that folks have put out there for classifying bias, for like even Miller is trying to add structure to explanations. And these are great to at least start having this conversation to help us negotiate these values. But as time goes on and things might change, context of every problem is different. The AWS case, or the Z Corp case, was different than the X Corp case of babysitting. So because of that, we kind of have to remember that if we have a checklist mentality, we might miss out on things. And as such, there really is no substitute for thinking.
Adrian is lurking behind us, which means that we are both out of time and fortunately done with our presentation. I kind of want to get him a giant shepherd's crook so he can just pull us off stage. Yes, if you have...
That's not necessary. No, first let's thank our speakers for a great presentation. It was really authoritative and thought-provoking. So now, not as a substitute for thinking, but hopefully as a complement to thinking, we have time. We just have 7 minutes to take questions. Please, if you can, please stay for these questions. And also, I hope that our speakers will be able to stick around a little bit afterwards for more questions if we run out.
And actually, David Robinson, who's over in the corner there waving wildly, has suggested that if we want to keep talking about these questions and keep thinking, that what we should do is go as a group to find lunch. and David has volunteered to lead us. So I imagine that we will gather outside the room if you're interested in sort of following along with us to continue having an interesting discussion here. So I hope these discussions were thought-provoking and fruitful, and I hope we can continue them through the questions and after.
Fantastic. Thanks very much. We have 6 minutes. Please, if you'd like to ask a question, please come up to the microphone. Maybe I'll just start with a question. So in this process of negotiating together to define the problems, I wonder if we can think back to one of the things you said near the start of this talk, which was that, I can't remember exactly what it was, but it was something like a mathematical fairness constraint is not fairness. But do these kinds of technical approaches, which quite a lot of the people here in the audience maybe can be thinking about, is that one helpful input to be adding into the process of trying to figure out together what it is that we're trying to achieve?
Yeah, that's a great question, and the answer is absolutely. A lot of times when we build mathematical models, right, I did say they're mathematical fictions, but nonetheless they can actually add stylized examples and actually add more structure, and through our uses of theorems and formal logic we can deduce things that otherwise might have been too fuzzy for us to figure out before. Because like math is very precise in its language, and as we saw here, language is very imprecise when we try to negotiate values. So there is a lot of structure, there's a lot of value to that as well, but it's also about recognizing that just because I have a mathematical definition doesn't mean anybody else's viewpoint is not valid anymore. So it's about understanding what you can bring to the table and your style of reasoning for this.
I would also say that the math helps us sort of negotiate and navigate the trade-offs, right? It's a tool, and there's certainly a lot of value to be had from using building and using these data-driven decision-making systems, and maybe they're not appropriate in every case, or maybe we need to put some guardrails up in certain cases. But I think if we want them to be usable in socially important contexts, we have to know how to deploy these kinds of abstract definitions. And to me, they're more like measures than definitions. So what I imagine, and I don't know exactly how it works yet, but is that there's some sort of development process, some sort of model development life cycle, like a software development life cycle, where we go through and we gather requirements, we think about them, we iterate on them, and then we continue to iterate on them as things develop, and maybe through that process we do some evaluation which involves these kinds of fairness definitions as a guidepost to say, hey, here's something that we thought might be problematic, and indeed we've discovered in this specific case it actually is a problem, and maybe we have to do something about it here. So that's the reaction. You had a question, I think.
I have some suggestion. That just a suggestion from the machine learning community. I'm thinking that okay, machine learning or artificial intelligence provides for us some solution, and now it's our responsibility that accept that solution or judgment or not. But when we are coming to say no to that judgment, there is other conflicts that people are saying that okay, is the answer of machine learning or artificial intelligence. So in this case, what do you think if we have another AI on top of that we are starting to negotiate with the AI and consider all of actually comments from people, from AI, and now reach a fair comment or something that we can say that is it positive judgment or everyone would be happy at the end.
So I think that's interesting. I think that's often a reaction that machine learning people have, is this idea that there really is no difference between, basically the idea that humans are just machines that are implemented with different kind of hardware, and that means there's nothing particularly special about humans making a decision, about humans trying to solve the problem, and what we can do is somehow build a sort of sufficiently advanced AI sometime in the future, which can kind of hybridize these definitions or help us do that negotiation. I have a little bit of trouble with this idea for a couple of reasons. Not because I want to engage in this question of like what is intelligence or what does it mean to be human or not human, but I think we talked a little bit about it with the dignitary requirements in the GDPR, that there is a sense that if it's a machine that's making decisions about you, regardless of how advanced that machine is. There is a sort of fundamental human dignity aspect to having decisions made about you by another human, and that your sense of self-worth is somehow validated by that decision process in a way that it wouldn't be through a machine. That's sort of the most coherent thing I have to say on that topic. You were next in line, I think.
Hello. Do you recommend any practical tools that help you to detect such biases through data or model exploration in your problems?
So we're laughing at each other because we started a project over the summer looking at the tools that exist and trying to figure out what they do and don't capture. And you might imagine that there are tools out there that capture all of the kind of fairness metrics or definitions that have been proposed in the literature, and there really aren't. There really isn't a tool that captures everything. There are a whole bunch of these tools that are open source now. You can search around for them. But there isn't really a lot of a sense of how you would deploy them into a workflow, and I think that's what's missing. And so I think this workflow idea that I alluded to earlier is an interesting one, and it's definitely something that's a good space for research that I don't think we have great answers for.
Okay, thank you.
Thanks. That's actually a great idea. It would be great if you're comfortable even publishing some preliminary work there, or we can work together on putting something together.
Well, I don't want to put Adrian on the spot, but actually I think the UK is pretty far along here, where there's like a public body that thinks about these issues that Adrian is actually part of, that sort of is meant to do stakeholder engagement. There are that's not to say there's no work on this, right? There's a project out of the University of Washington called Diverse Voices that looks at how you would, in a structured way, bring minority voices into a technical design process and solicit requirements. I think that's very interesting. There are notions that come out of HCI about building user panels that are relevant here. I don't know a lot of details about any of those things, but they are out there and worth considering.
Fantastic, thank you. So again, there will be time right afterwards to speak to these guys and potentially to go out for lunch with them. But unfortunately, we have to wrap up here. So please, let's thank Deirdre. Unfortunately, you couldn't be here, but contributed, and Josh and Nitin for a wonderful presentation.